Hello guys, I am Job Quinto Sagario and I am here because I love to give you a presentation about the subject number theory, and our topic we'll be discussing today is the Euler Phi Function. So before we start, let us read this quotation first from the unknown author. So it says here, mathematics may not teach us how to add love or to minus hate, but it gives us every reason to hope that every problem has a solution. So what is the Euler Phi function? The Euler Phi function is written of the pi of n for positive integer n. Pi of n is the number of non-integer or a non-negative integers are less than n that are relatively prime to n. In other words, if n is greater than 1, then pi of n is the number of elements and the u sub n, and the pi of 1 is equal to 1. So here are the formulas on finding the pi of n. So if n is a prime number, then pi of n is equal to n minus 1. And the second formula is, if the n is not a prime number, but it is a product of two different prime number, then the pi of n is equal to p minus 1 multiplied by the q minus 1. The third equation is, if both numbers are composite or either, then pi of n is equal to n 1 minus 1 over p sub 1 multiplied to 1 minus 1 over p sub 2, and so on. So let's take the example number 1. So this is the list of prime numbers from 1 to 100. There are 2, 3, 5, 7, and so on. So you can use this formula to all prime numbers. Just for example, this in the screen. So pi of n is equal to n minus 1. So that is our formula. And then the pi of 2 is equal to 2 minus 1. And then the pi of 2 is equal to 1. And then the pi of 3 is equal to 2. The pi of 5 is equal to 4. The pi of 7 is equal to 6. The pi of 11 is equal to 10. And the pi of 13 is equal to 12. And the pi of 17 is equal to 16. And the pi of 19 is equal to 18. So example number 2. If the n is not a prime number, but it is a product of two different prime numbers, then pi of n is equal to p minus 1 multiplied to q minus 1. Take for example this, the pi of 21. So we all know that we can multiply both prime numbers to get this 21, the 3 and 7. So just follow the formula, 3 minus 1 and then 7 minus 1, multiply it together. So 2 multiplied to 6 is equal to 12. So the pi of 21 is equal to 12. Okay, let's proceed to example number 3. So you can also solve a bigger number using the distinct prime numbers. So this is the formula. The pi of n is equal to the n 1 minus 1 over the pi sub 1 multiplied to 1 minus 1 over p sub 2. So we need to find the pi of 5,000. So n is equal to 5 raised to 4 multiplied to 2 raised to 3. It is equal to 5,000. But using this formula, you only put the distinct prime numbers, the 5 and the 2, to the 2 p's. For example, pi of n is equal to the n 1 minus 1 over p1 multiplied to 1 minus 1 over p2. So the pi of 5,000 is equal to 2,000. So the pi of the 5,000 is equal to 2,000. Okay, hi guys, thank you so much for watching this video. Thank you guys. I hope you learned a lot, and God bless you all. Mwah, mwah.